E is the electric field developed along the length of conductor due to flow of electrical energy through the conductor. If V is the voltage drop across the conductor and L is the physical length of conductor, then E equals V/L-2. The current density J is resulted within the conductor due to the flow of electrical energy through the conductor. If I is the current flowing through the conductor and A is the cross-sectional area of conductor, then by the definition of current density, J equals I/A-3. Now combining equations 1, 2, and 3. I/A equals sigma V/L. V equals L/A sigma I4. The term in parenthesis is constant and let us denotes it by R. V equals Ri. This is the Ohm's law form in circuit analysis. By the definition of Ohm's law, the current flowing through a conductor is directly proportional to the potential difference applied. I proportionality V. The proportional constant is called resistance parameter of the conductor R. I equals V/R. R equals V/I. The unit of resistance is volts per ampere and is given the name ohm. 1 equals 1 volt per ampere equals 1 V/A. From earlier calculations, V equals L/A sigma I. R equals L/A sigma I. Sigma is the conductivity of the conductor, which is the measure of conductor's ability to conduct electric current. 1/sigma is the reciprocal of electrical conductivity called electrical resistivity, denoted by the symbol ρ. Resistivity is the measure of a conductor's ability to resist the flow of electric current. Resistance of a material, proportionality resistivity of the material. R equals ρL/A. Resistance of a conductor can be defined as the conductor's opposition to the flow of current through it. Resistance is a property of an object like conductor. Resistivity is a property of a material from which the object is made. Resistance value of a given resistor can be read from the resistor color code given on it. What is the power rating of a resistor? Power rating of a resistor is the maximum value of power, combination of voltage and current, a resistor can handle. If the input power of the resistor is greater than this value, resistor may damage. Power rating of a resistor is also called wattage. Resistors have wide range of power ratings from 1/8 to 1 watt. Resistors with more than 1 watt are called power resistors. VI characteristics of a resistor are the relation between the applied voltages and the current flowing through it. From Ohm's law, we know that when the voltage applied across the resistor increases, the current flowing through it also increases, i.e. the voltage applied is directly proportional to current. The above specifications are valid in case of a pure resistance, i.e. ideal resistor, and the temperature is constant. In practical conditions, these values may vary depending on the operating environment, and the characteristics might be different from the ideal linear values.